Thank you very much, Alex. Hello, everyone. I'm very pleased to be here today. The first slide is just to remind myself that there are human skeletal remains in some of these slides. So if you don't want to see them, please feel free to vacate for 10 or 15 minutes. Okay, so over the last under 20, 25 years or so, commercial archaeologists have been increasingly involved in infrastructure projects, and that has included quite a few burial grounds. Now, with large burial grounds, there are challenges, ethical challenges, logistical challenges, but they do hold promise in that they can produce an awful lot of information about the experiences, lives, and health of past communities. The assessment of large assemblages of skeletal remains help us to identify the potential for further study and also help us to identify research questions. And the increasing scale of some of these burial grounds really provide a significant opportunity to answer some of these research questions. Some of the sites that I've had at least some slight involvement in are on the screen here. There's Crossrail that Jay talked a lot about previously. There was the Black Death burial ground at Charterhouse Square, 25 individuals, and the large New Churchyard burial ground outside Liverpool Street in London, and that was about 800 individuals, and then a small Roman cemetery underneath. And then there was HS1 outside the back of St Pancras Station in London. That was the old St Pancras Church burial ground. That was 780 individuals, including some emigres from the French Revolution who settled in Somerstown. Then, as has been mentioned already, A14, 94 inhumations, 186 cremations. This was obviously a different nature of a site, a more rural environment, more of an emphasis on prehistoric and Roman burials, a lot more cremations compared to inhumations. Then a huge project in London, the Thames Tideway Tunnel, really massive, the super sewer, one individual, that's all, lets us down a bit. Very interesting individual, but only one, and I think we've also got one tibia. So anyway, we're getting there. And then, of course, HS2, 13,740 inhumations, 149 cremations from 53 different sites. About 91% of the inhumations come from just 3 post-medieval burial grounds. And I just want to go through those 3 very, very quickly just to show you what they are. Firstly, in London, St James Gardens in Euston. This was the biggest one. A huge structure covered the whole area of the excavations. We had obviously lots and lots of bodies, thousands and thousands, and this meant that we had extra resourcing we had to provide on site. So we had 10 trainee osteologists who were doing on-site assessment throughout the course of the excavation. Then just over there somewhere, there was Park Street, Birmingham. This was a site where we were lucky enough to have quite a few people training from the local area, volunteers and trainees from a diverse range of backgrounds, really, who came in and were trained and then became fully integrated into the project team. And that was a really nice way of working. This is the one of the big tents there. This is the north half of the burial ground. Very, very good skeletal preservation. And as you can see, wonderfully clear grave cuts. The third site was St Mary's Church in Stoke Mandeville. This was a little different in character. It's a churchyard, a rural parish churchyard, still an awful lot of burials, and again, under a big tent. And this meant that, again, we had plenty of room out in the countryside. We could expand it a bit, and the people who were running the engagement opened up a field museum to invite people in for site tours and lectures, and also for training. And this particular image shows some osteologists training some local people in how to record a skeleton. So when you work in osteology and other archaeological work on burial grounds, you need a lot of help. It's quite complicated. There's the law, there's logistics. That you need some help, some advice. So we're very lucky that we do have some published works from a PABI, in this case, an advisory panel on Christian burial grounds. And this is really sort of a Bible for our work. It really helps us when we're working with burial grounds to make sure we're doing things properly. That's the green one on the left-hand side, your left-hand side. They also published a very useful book on large burial grounds and specifically how to sample them, how to deal with them, how to produce the best results from a project based on a large burial ground. And also at the end, they produced a lot of case studies that also help to understand what you want to achieve from these large projects. The picture on the front of that one is actually from the new churchyard, better known as the Bedlam Burial Ground, outside Liverpool Street for Crossrail, as Jay mentioned earlier. And I just want to briefly touch on the methodology we used there, simply because I think it shows how methodology developed early on in the programme can actually work its way through the whole project and produce quite exciting results if you get it right, or in this case, if you're lucky, I don't know, maybe it's a combination of both. But what we did was, due to time pressures, we couldn't excavate the whole burial ground and keep all the skeletons. Some had to be sent for reburial. So the burial ground was divided into different grids, and we had two different methodologies of working with the burial ground. The first one was, in a way, standard excavation. You'd have archaeologists on site excavating, recording, planning, and then lifting the skeletons, bagging them up, sending them back to the office, getting them processed, put into boxes, given to the osteologists, who would then assess the skeletons in the laboratory, and those skeletons would go forward to be subsampled for full analysis at a later stage. That's the method one in the grey there. In the red and the yellow, we have the method two. Method two started off in a similar fashion to method one. Full recording, archaeological excavation, planning, but when it came to the lifting, we had on-site archaeologists who did a quick assessment of the skeleton while it was being lifted. Once that was done, the skeletons were put into red bags and sent straight off for reburial. So we had a record, not as a complete record as you'd had with the method one, but we had some record of those burials. Now, the clever thing that they developed with this particular system was that they allowed some leeway. So in the method two category, you were allowed to keep approximately 10% of burials. This meant that if we found any particularly interesting burials in the method two areas, we could keep them. So these are burials with finds, with nameplates, particularly unusual burials, or those with particular pathological conditions. So we could select ones to keep, even though they were in the area where we were supposed to be sending them straight for reburial. And this proved to be very, very useful in this case, because over here, that is a method two area. And of course, that's where we found a massive plague pit. So under normal circumstances, we would have had to send it all off for reburial straight away. But because we had this leeway, what we called category B skeletons, we could keep them all and then process them, do the assessment actually in the lab, and do further work and further analysis on these burials. This is a quick photo of the plague pit itself, dated probably 1603, 1625 in the end from the radiocarbon dating. So early 17th century plague outbreak in London. And we ended up with, I think, a minimum number of 42 individuals. It was truncated, so originally there may have been 100 or more in that pit. And because we could retain them, we could, in our program for full analysis, we could incorporate DNA analysis into the program. And in this case, it was with the Max Planck Institute. And they did analysis on the teeth and found plague DNA, and they used this DNA information together with other sites that were well dated from around Europe to do a little map of the second pandemic as it progressed through Europe. And also added actually the burials to the phylogenetic tree as well. So it's now part of the evolution of plague from doing the DNA on these burials. The DNA was very well preserved, so they could get the full genomic information from it. And the great thing about this is that it tells you something about the evolution of Yersinia pestis, and it also tells you something about the pathogen-human interaction of the disease, how it behaved over time. And as far as medical science is concerned, it probably tells you something about how emerging diseases and re-emerging diseases might behave in the future. So it was a great result, and it just shows that some forethought in the development of the methodology right at the beginning of the project can really pay off. Just related to this, and only briefly, because I know we've been talking about the A14 a lot, this is one example of, again, biomolecular work that was done on a burial at the on the A14, to rural Cambridgeshire. This was an isolated burial of a male individual who died between about 18 and 25 years of age. They were near to a Roman road, and there was nothing really else around them, so quite isolated. And we did isotope work and DNA work on this individual. The DNA went to the Crick Institute. They came back and said, we've got someone unusual here. It looks like they're related to people who originally came from the Caucasus. So the great thing about this was that we had already sent off a sample for isotope analysis, and we could, without the two different specialists knowing, we could wait for the results from the isotope people to see if their results actually agreed. And what the isotopes told us in the end was that actually this person wasn't just related to someone who came from the Caucasus, they did actually come from the Caucasus themselves. And the dietary isotopes told us that they gradually moved across Europe from an early age. And there's a possibility that this may be, from the dating at least, this could be one of the Sarmatian cavalrymen who was brought to England and put into the Roman army by Marcus Aurelius after the Marcomannic Wars. So again, this shows how different shreds, different aspects of biomolecular work can be used to complement the skeletal analysis. And in the end, of course, we had the Crick and Durham University who did the isotope work, talking to each other and producing even more interesting work as well. So the collaborators were talking to each other, talking to us, and it was a nice circle of results. So just a couple of points I wanted to make about biomolecular work. You need to be prepared, and we try to adapt our on-site assessment work to prepare for any future analysis or any future sampling. What we've used recently is something we call recovery categories. That's where we make a little note of skeletons that have a dentition that is complete enough that you can sample it if you want to, and also skeletons with petrous temporals and with ear ossicles, because they are good for DNA work, in particular for ancestry DNA. The teeth you can also use for pathogen DNA and also for isotopes. So what this means is that we've got this information as soon as we finish the assessment, and then this can be built in to the research questions and also into the UPD, and it means that you don't have to go back and look at the skeletons again, because that's already been done. Time is money. And it means that you can prepare the budget and actually form a post-excavation project based on those results. Obviously, you want to be selective. You can't sample everything, but we've sort of found that it helps to be restricted in sampling. It's quite a healthy thing because it makes you think more. And if you're more disciplined, I think you can perhaps produce a better scheme, a better idea of what you want, and you can target it more towards the research aims. Collaboration with external partners. This always occurs to me that if they're interested in the results, then that's a bonus. If they're not interested in the results, maybe they're telling you something, because a lot of these people, a lot of these boffins, are actually originally archaeologists and they know an awful lot about archaeology. So if they're not interested, then maybe think again and ask yourself if you're asking the right questions. And just finally, a few lessons learned that I wrote down. Planning, post-excavation work, it begins at an early stage, as I've said. You want a consistency of approach, as specialists will always tell you, but always be prepared to be flexible. Not every burial ground is the same. Time and budget constraints, you want a targeted approach, obviously. Innovation, again, if you can introduce new technologies, new methodologies, it's always worth looking at. Collaborative work with academic partners, you get a flow of knowledge in both directions, which is great. And then if you get an integrated sampling program, you can create efficiencies. And we all know that sampling human remains is difficult because you don't want to destroy any more of the skeleton than you have to. And what you can do, of course, is have a good plan about how to bring about that sampling with producing the best results. For example, if you take a tooth for DNA, you can send that tooth off. You can use the same tooth for isotope analysis, and then you can use the collagen produced in the process for radiocarbon dating. So that way you can get more bang for your buck, so to speak. And I think I'll finish there. Thank you very much.